that matter exists in three states. That is, solids, liquids, and gases. If we supply heat energy to a substance, its dimensions increase. This is called thermal expansion. Let us conduct some experiments to understand the thermal expansion of matter. Thermal expansion in solids can be understood with the ball and ring experiment. Take a metal ball and a ring. The diameter of the ball should be such that it just passes through the ring. Heat the ball for some time over a burner. Now, try to pass it through the ring. You will observe that the ball does not pass through the ring. This is because the volume of the metal ball increases on gaining heat energy. The increase in the volume of matter on gaining heat energy is called expansion or thermal expansion. Let us conduct another experiment to understand thermal expansion in solids. Take two identical wooden blocks. Place the two blocks on a horizontal surface separated by some distance. Take a copper rod and place it on the two wooden blocks. Fix one end of the copper rod to one of the wooden blocks. Leave the other end of the copper rod free to roll over a cylindrical pencil placed on the other wooden block as shown here. Suspend a small weight or plumb from the copper rod such that the copper rod is firmly in contact with the wooden blocks. Attach a paper pointer at one end of the pencil such that the pointer can move over a circular scale as shown here. Now, place a spirit lamp between the wooden blocks, under the rod, and light it. As the copper rod gets hot, it expands. As the rod expands, the pencil which is in contact with the rod rolls over the wooden block. The paper pointer attached to the pencil rotates on the circular scale. This confirms that the rod expands on heating. Let us now conduct an experiment to understand thermal expansion in liquids. Take a round-bottomed flask and fill it with colored water up to the brim. Close the flask with a single-holed rubber stopper. Now, insert a capillary tube into the flask such that some water from the flask gets into the capillary tube and reaches a certain level. Mark the level of the colored water in the capillary tube. Now, heat the flask over a burner. Observe the level of water in the capillary tube. As the flask is heated, the water expands and the level of water in the capillary tube rises. This is due to the thermal expansion of water. Now, stop heating the flask and observe the level of water in the capillary tube. The level of water goes down as the temperature of the water in the flask decreases. Thus, liquids expand on heating and contract on cooling. Let us now understand thermal expansion in gases with the help of an experiment. Take an empty test tube and close its mouth with a single-holed rubber stopper. Take a capillary tube in which a small amount of colored water is trapped. Insert it into the test tube through the single-holed rubber stopper. Hold the test tube with the test tube holder and heat it over a burner. Observe the level of colored water in the capillary tube. On heating the test tube, the air in the test tube expands and pushes the colored water up. Now, stop heating the test tube. When the test tube is cooled, the air contracts and the level of the colored water comes down to its original level. This can also be observed without heating. Hold the test tube tightly in your palm. The heat from your palm transfers to the air in the test tube. The air expands and pushes the colored water up. Now, hold the test tube between your fingers. The air in the test tube cools and contracts. The level of the colored water comes down to its original level. This activity confirms that gases expand even when they are exposed to very little heat. Thus, gases expand on heating and contract on cooling. Of the three states of matter, liquids expand more than solids and gases expand more than liquids. Thermal expansion of substances has many applications. Let us discuss one of them. Blacksmiths use the principle of expansion on heating and contraction on cooling to fix the iron rim onto the wooden wheel of a bullock cart. The radius of the iron rim is slightly less than that of the wooden wheel. The iron rim is heated to red hot so that it expands and its radius increases. It is then slipped over the wooden wheel and cooled by pouring water. The iron rim contracts on cooling and gets tightly fixed to the wooden wheel.